Let's look at the question, array partition. We are given an integer array names that have two n integers. We group these integers into n pairs. From A1, B1 is a group to A2, B2 is another group, and then blah, 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 until AN and BN is the final group. So that's the sum of minimum of AI and BI for all I is maximized. Then we just return the maximized sum. The first example, we input names 1, 4, 3, 2. By ignoring the ordering of elements, we just use brute force to exhausting the elements. So we get all possible pairing. They are 1, 4, 2, 3. So the minimum of 1, 4 is 1. The minimum of 2, 3 is 2. 1 plus 2 is 3. The second possible pairing, 1, 3 and 2, 4. The minimum of 1, 3 is 1. The minimum of 2, 4 is 2. 1 plus 2 is 3. The third possible pairing, 1, 2 and 3, 4. The minimum of 1, 2 is 1. The minimum of 3, 4 is 3. 1 plus 3 is 4. So the maximum possible sum is 4. We just output 4. Obviously, brute force won't help here. How will we make pairs to get a result? There must be some pattern. Do you observe that the minimum element gets added to the result in sacrifice of the maximum element? In the first possible pairing, 4 and 3 are the maximum elements, but they are sacrificed by 1 and 2, which is the smaller one. So think of something else. We just store the array into 1, 2, 3, 4 and try to find a pattern. 1, 2 is a group and 3, 4 is another group, so we can maximize the sum. The second example, if we input names is 6, 2, 6, 5, 1, 2, then we store the array into 1, 2, 2, 5, 6, 6. So the optimal pairing is 1, 2 is a group, and then 2, 5 and 6, 6. So the minimum of 1, 2 is 1, the minimum of 2, 5 is 2, the minimum of 6, 6 is 6. 1 plus 2 plus 6 is 9, so we output 9. Let's take this pattern into an algorithm. First, we take the second example as our input, which is names is 6, 2, 6, 5, 1, 2. So we sort the names into 1, 2, 2, 5, 6, 6. Then we take the range from index 0 to the index of length minus 1. We group up every two elements, which is start from index 0, index 2, and index 4. So we can find a pattern, which is I is always incremented by 2 every time, so we can take the first element, the third element, and the fifth element. Before we do that, we need to set a available result and initialize it to 0, and then we add the element into it, which is names at 0, names at 2, and names at 4, and which is 1 plus 2 plus 6, which is 9. Then we return 9. Let's turn the algorithm in Python. First, we define a function, array, pair, sum. The parameter is self and lambs, and we return an integer. So first thing we need to do is lambs.sort to sort the array, and then we set a variable result is start from 0, and then we set a for loop to loop a point I in range from first element to the last element, and every time increment by 2, so the pointer is every time incremented by 2. So the result is the sum of all the elements 0, 2, and 4 in the second example. So then we just return the result. Yeah, that's how it works. Let me try to prove this algorithm. Assume in each pair I, BI is greater than or equal to AI. Denote DI for the distance between AI and BI, which is the absolute value of AI minus BI. Given 1, so DI is BI minus AI. We denote SD for the sum of all the distance from D1 plus D2 plus D3 plus blah 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 plus Dn. Then we denote SM for all the minimum, which is minimum of A1, B1 plus minimum of A2, B2 plus blah 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 plus minimum of AN and BN. So the biggest SM is the answer of this problem. Given 1, so the SM is A1 plus A2 plus blah 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 plus AN. we denote SA is A1 plus B1 plus A2 plus B2 plus blah 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 plus AN plus BN. So SA is the sum of all the elements. It is a constant for a given input. So we can factorize BI into AI plus DEI. Then we can factorize SA, which is A1 plus A1 plus D1 plus A2 plus A2 plus D2 plus blah 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 plus AN plus DN. So we can find a pattern here because A1 plus A2 plus blah 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 plus AN is SN, and D1 plus D2 plus blah 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 plus DN is SD. Finally, we can simplify SA into 2 times SM plus SD. So 2SM is SA minus SD. So SM is SA minus SD divided by 2. We can compare SA and SN. SA is greater than or equal to SM. So if we want to get the maximum of SN, we need to remember SA is a constant. Then we need to make sure that SD is as small as possible. So this problem becomes finding pairs in an array that makes sum of DI as small as possible. So remember, DI is the distance between AI and BI. Let's try to draw some one-dimensional coordinate system. In the first case, A1 and B1 is adjacent. In the second case, A1 and B1 is common across A2, so the D1 and D2 is greater than the first case. And in the third case, A1 and B1 is common across A2 and B2, so this time the D1 is the biggest, then even bigger than the second case. So apparently, the case 1 has the smallest SD, right? So the sum of the distance of adjacent element is the smallest.